Ever find yourself hitting a wall with your computer's power? When you're deep in a huge creative project or maybe tackling some complex scientific modeling. Well, today we're diving right into that. We're looking at AMD's brand new Ryzen Threadripper 9000 series CPUs. Our mission really is to unpack what these incredibly powerful new processors actually are, who they're really built for, and maybe most importantly, what does their launch, which is like right around the corner on July 31st, what does that mean for the whole high-end desktop scene? We've got some interesting details pulled from a Tom's Hardware article to help guide us through this. Okay, so the big news. AMD officially took the wraps off its Zen 5-based Ryzen Threadripper 9000 series. We're talking like up to 64 cores, a massive 128 threads, and boost clocks hitting 5.4 gigahertz. I mean, these are serious numbers, but where do these new Threadrippers actually fit in AMD's lineup, especially with the PRO series also out there now?
Yeah, that's a really good question because placement is pretty critical here. The chips, they're specifically designed to fill that, let's say, important gap between the mainstream Ryzen chips and the recently launched Threadripper PRO 9000WX series. The key thing is these non-pro versions. They're really aimed at enthusiasts, creators, developers, people who need just extreme performance. Think rendering, complex video edits, heavy AI stuff, that kind of workload. They deliver that raw multi-threaded power, but maybe without needing all the workstation features like, say, octa-channel memory or the full PRO platform cost.
Right. And speaking of cost, what's really caught my eye is that AMD kept the pricing the same. It's unchanged from the last gen, the Threadripper 7000 series. So, for instance, the 64-core 9980X, still $4,999. The 32-core 99970X is $2,499. And the 24-core 9960X, that's $1,499, which is, quite different when you look at like a 96-core PRO chip at nearly 12 grand.
Exactly. It's a very deliberate signal, I think. They're making this level of performance potentially accessible to a broader slice of those high-end users, trying to capture that creative pro or that power user who craves server-level horsepower, but maybe doesn't need or want to pay for all the enterprise validation and features of the full PRO line. It's smart market segmentation, really.
Okay, makes sense. And these chips, they slot into the AMD TRX 50 platform, right? So that gets you 4-channel DDR5 6400 memory support and up to 80 PCIe 5.0 lanes, which effectively is double the memory bandwidth of, your typical mainstream desktop. For someone really pushing the limits, content creation, data analysis, what does that extra bandwidth actually unlock, like in the real world?
Oh, it unlocks huge potential, especially for those really heavy data-hungry tasks. Think about large AI data sets or incredibly complex 3D scenes for rendering, doubling the memory bandwidth plus having those 80 PCIe 5.0 lanes. It just means your GPUs, your NVMe drives, they can feed data to the CPU way faster. It cuts down bottlenecks significantly. Plus the fact that overclocking is still supported on TRX 50. That means enthusiasts can still squeeze out even more performance if they want to.
Right. Now, beyond the specs and the platform, AMD is making some pretty bold performance claims. They're saying the flagship 9980X gives up to, 108% better performance than Intel's 60-core Xeon W9 3595X in heavy compute tasks. And the 32-core 9970X is supposedly 137% faster than Intel's 44-core Xeon W9 3575X. How do those percentages translate to the user?
Yeah, they're impressive numbers, and they're not just, theoretical. They should translate into real, tangible speed-ups in workflows. The source specifically mentions big games and benchmarks like Cinebench 2024, Adobe After Effects. But where it could be really impactful is in AI inferencing and processing large models. That's where having tons of cores and that high PCIe bandwidth really counts. And the full AVX 512 support with the 512-bit data path, that's a game changer for scientific computing, complex AI, high-end video encoding. Basically, it means you can tackle stuff on your desktop machine learning, complex simulations that might have needed dedicated server gear before.
Okay, so it's clear AMD is being super aggressive here. They're even talking about reviving the HEDT market. But the source, Tom's Hardware, it also points out a counter-argument, doesn't it? What's the thinking that these are actually more like workstation CPUs?
Right. That's the nuance here. Well, AMD positions them as HEDT or high-end desktop. Some argue they're basically workstation chips because of the total platform cost. A TRX 50 motherboard isn't cheap, maybe around $600 or more, and the RD memory they use is definitely pricier than standard desktop RAM. So yeah, while the CPU price itself is aggressive for the core count, the cost to build a whole system pushes it into territory that many would just call a workstation. Not really consumer HEDT in the traditional sense. It definitely raises an interesting question about how we even define these market segments now.
That distinction definitely matters for anyone buying, yeah. But AMD seems pretty clear on their goal, giving that flexibility and raw power without hitting the really prohibitive costs of the full PRO line and taking the fight directly to Intel's Xeon W series.
Exactly. Ultimately, these new Threadrippers, they really complete AMD's Zen 5 desktop picture quite nicely. It just shows how aggressive their strategy is across the board, from consumer right up to professional desktops. They're really leveraging their architecture to offer serious power and kind of redefine what a single desktop machine can actually do.
So, wrapping up, what does this all mean for you, the listener? Well, it kind of invites you to think about how these big leaps in high end desktop power might change things. Could it reshape your creative workflows, massively speed up AI development you're doing, or maybe just expand what you thought was even possible on a high performance machine you could actually own? It really makes you wonder, doesn't it? Where could this mix of extreme power and pretty aggressive pricing actually take innovation next?